really glad to. So we have a visiting scholar from Spain, from UNED, which is Spain's distance university, and Dr. Luis de la Torre. And Luis is an expert in cyber physical systems and IoT, and also a blockchain developer. So without further ado, I'm going to just turn it over to you to talk about your amazing project, DecentraLabs.
Great. Thank you very much, Vicky. Thanks. Thank you. Well, yes, as Vicky said, my name is Luis de la Torre, and I am with UNED. I am an associate teacher there, but I am also co-founder of a small startup called Nebulous Systems. And I am here today to talk to you about DecentraLabs, which is a project that has been founded by the European program called Next Generation Internet Sargasso. And it is being led by Nebulous Systems, but in collaboration with the blockchain group at UBC. So in short, the idea of DecentraLabs is that we aim to transform how online laboratories are accessed and sustained, it's a very important word, globally, using blockchain technologies, and therefore the name. So these are the contents of today's presentation. I will start with some context about who we are and how we came here and everything. Then I will talk about online labs, what they are, their advantages, but also some limitations. Then I will present our vision with this project, what we want to achieve. And after that, I will try to explain how blockchain technologies enable us to make that vision a reality. And finally, I will talk about DecentraLabs and its community, the community that we are forming around the project. So let's start with the context. Well, UNED is a university based or located in Madrid, in Spain. Or better said, its headquarters are located in Madrid because we have associated centers and students scattered all over the country. As Vicky mentioned, we are a distance education university. Not only that, but we also have associated centers and students in a lot of countries abroad. So many capital cities in different countries, especially South America for the language, have an associate center of UNED and students that are enrolled in our courses. And this also means that we have a lot of students. Actually, we are the second biggest university in Europe in terms of students. In 2024, we had 180,000 enrolled students. So just think about that number for a second, 180,000. Can you imagine how our evaluations are? A nightmare, yeah. But you know, no university is perfect. And of course, in this distance education context, distance experimentation is also very important, is key. And that's why my group has been working on developing a suite of online laboratories, virtual or simulations, and remote with real accessible hardware in real time. And we have been doing this for more than 20 years, so that's why we have lots and lots of them. And you can see we always have the virtual simulated version of a process or a system, and then we also make the remote with the real hardware accessible version for the same system or process that we want to offer to our students. Now let's talk a little bit more about what online labs are. We have seen a few examples from my group. Well, the first thing is not only what they are, but why are they interesting, especially for, not only distance education universities. How about traditional universities? Why would they want to use them or have them? Well, I would say the most important motivation for that is the one I'm going to present in the next slides. So for that, I'm going to use two fictional characters. Meet Amanda and John. They are two students who meet in the lab classroom for the first time. And so they go to the table with the hardware equipment, and Amanda says, "Hi, John, we are lab partners today." And she asked, "Have you read the lab practice?" And John says, "Oh, actually I haven't." Because anyone who has been in a lab has lived this. Students go to the lab and they haven't even read the lab practice guide. So the first thing they need to do is spend time reading instead of tinkering or experimenting. Luckily, Amanda says, "Well, that's okay, I did, because girls are more diligent than boys normally." And they also, after they start working, they face another problem. Amanda says, "Wait, how do you turn this thing on exactly?" And John says, "Beats me, because he has no idea, neither. I'm going to call the teacher." And of course, as it happens in lab classrooms, the teacher is busy, he's checking on other students, he's solving doubts for someone else, he's alone or maybe with some lab technician. They are not enough to carry things on time. So when he's finally free, he goes and checks with Amanda and John, and he says, "Guys, haven't you started yet?" And they say, "Well, we managed to turn the equipment on and connect all the wires. Yeah, but we do not know how to exactly measure this, so we are stuck." And of course, the teacher says, "That's too bad. You only have 1 hour and a half for this lab session, and 30 minutes are already gone." And John says, "Damn, can't we stay longer to finish our experiment, to get all the measures that we need?" And of course, because teachers, we are people super busy, he says, "I'm afraid not. I have to give a class after this." And Amanda thinks, "I wish we could have more lab time." And I think this thought is the main motivation or the main reason why even traditional universities would be interested in using online laboratories. And also because we care about how our students feel and what they think, don't we? Well, we should. So I have talked about the first advantage, time, by sharing laboratories online and making them accessible 24/7. You can provide more lab time to your students, even with the same systems that are available in your university. But there are other advantages, those 4 there. The first one is variety. Think about a student or a researcher in a smaller university or in an institution with less resources, with less equipment. By sharing laboratories online, you can give these people access to experimentation tools they may not have wherever they are. So they have a broader catalog of lab setups, experiments, and research tools they can use. Then we have the advantage of flexibility, because again, being 24/7 online or with the potential of being 24/7 available and online, the users can decide from where and when to use the labs. In our case, in UNED, that's very important because our students have a lot of different schedules. They normally work, they have families, and they need this flexibility. This also has advantages in terms of accessibility for some handicapped people who may have some difficulties going to the lab in person. Then another important thing is value. Look, lab equipment, in most cases, remains idle for most of the time. Think on the evenings, the weekends, nights. Even during the peak hours, educational labs are used once in a semester or twice or 3 times for 1 week, something like that. But it remains idle most of the time. So the price or the cost per hour of use of the equipment is very high. But if you get to share that with others, the price per hour or per day or whatever you want to say decreases drastically. And moreover, if you turn that into a service, you can earn by doing that or get a revenue. And finally, security. Because you can think on many different experiments that are, that have hazard concern. For example, an experiment with high power lasers or high voltages or even radioactive samples. If you make it remotely operable, it is perfectly safe for the person doing the operation, at least at distance. A completely different thing is they may set something on fire and kill everyone in the building, but no solution is perfect, neither. So let's talk about what online labs are. As I said, basically we think of two different solutions, the virtual laboratories, the simulations, and the remote real accessible ones. You can also think on digital twins, which are somehow a mix of these two versions, and that would also be inside what an online lab in general terms is considered. There are also other terms, probably more modern or gaining track lately, which are self-driving labs or lab automation. They are basically the same thing, at least when you think about remote labs. So in an online lab, basically you have a simulation. Here we have this disk. This is a real picture of a motor, but it is not providing real video feedback from the laboratory. This is going to be animated only thanks to a mathematical model, which can be run either locally in the user's PC or in the cloud in a remote server. And of course, you can use a variety of tools to implement the model, like MATLAB, LabVIEW, Python, and many other options. Now, in the remote version, you replace the model, the simulation, with real hardware. So here we have video feedback in real time from the laboratory and a connection to the real setup. And the way you control that, it can be done with some of the tools that you would use for the simulation, like MATLAB or LabVIEW, or some specialized tools like Arduino, or even industrial software like the TIA portal from Siemens. And in terms of examples, you can think on online labs going from things like a relatively simple commercial didactical setup that you would buy from one of many distributors, to a custom industrial process that you have set up on your own, or even a robotic telescope that can be operated remotely, like this one from the STEM faculty in the Open University in the UK. And even data centers in which you need to somehow rent access, get the service for using the computational resources are not fundamentally different from what remote labs are technically or conceptually. Even here in UBC, you have a group, HainLab, working on lab automation. They are actually bringing solutions to automate experiments in chemistry, which has typically been a difficult field in which you are able to perform labs autonomously for a variety of reasons. They are doing a great job, and if you're interested in this kind of things, I recommend you to check on them. So as you can see, even in UBC, lots of examples, there is gaining track and interest in this kind of things. But online labs, despite all their advantages, also have some limitations. And one of the biggest one, in my opinion, is the way they are shared, when they are shared at all, or someone tries to share them. And I'm going to explain the process about how they are normally shared nowadays. So the first step is normally someone in an institution in A develops an online lab, deploys it with the intention so that their students, researchers, teachers can use it. Great. So in order to share this, well, first, this person in A should meet or talk with someone in a different place, in a different institution, in B, talk to him or to her about the online lab. The other person maybe is interested and say, okay, that sounds cool, I want to use it. And if the person in A says, okay, yeah, let's do it, I will share it with you, then they have to agree in some sharing terms to decide how that would work, and also in the mechanism to technically make that possible. Not only the sharing terms, but how will the users in B access the infrastructure in A, right? So this may not sound that complex when you say it like that, but believe me, it is complex and it has a lot of issues. First, A and B must know and talk to each other. A and B must negotiate an agreement, and this is not always easy. And finally, somehow the way that the users in B access the lab in A is not always solved, nor trivial at all. So let's focus particularly in the somehow, in how do these users access? Well, there are a lot of issues to consider and to solve. First, well, normally users in A do not have to pay to use the lab, right? Because they belong to the institution. But users in A or may not, depending on the sharing agreement that they have. Users in A normally access the system through their learning management system, their institutional virtual course platform. But what about B? How would that work? When you're sharing a resource that is limited, like an online lab, between at least 2 groups or more, you need something to manage the access. So if you are using a booking system for that, where is the booking system hosted? And if there is not a booking system, then what are you going to use instead to manage access? And then another question is, how do users in B get authorized and how they access the lab in A? What is the mechanism to keep security and to get all things done in place? And finally, if you are offering the lab as a service, whether it's free or not, if you are offering to someone, that someone wants to have some guarantees that it's going to work, right? So if people in B go and access the lab and it's not working, how can they prove that it is not? So lots of issues, and now it's time to present our vision, what we want to build and what we are trying to do in DecentraLabs. And for that, I have this short video. It is a nice video, less than 2 minutes. So please do not fall asleep. I assure you it's quite nice. And most importantly, I will be watching your faces, so stay alert. I'm watching. Okay, that's it. So, thanks. Thanks, Vicky. Okay, so how do we make that vision a reality? Let's talk about how blockchain helps us in doing that. And you may be thinking, damn, it was about time, right? I came to a blockchain talk and it's been like, I don't know, 15 minutes, something like that, and you have only mentioned the word maybe once or twice. Well, we have reached that point, so let's start with that. So this is the use proposal that we are launching, okay? And I'm going to use a similar diagram to the one I used before. So the starting point is the same. Someone in A deploys an online lab because they want to share it with their students and researchers. But then, in this case, what they are going to do is, in addition, they are going to establish the conditions for sharing the online lab in a smart contract in the blockchain. And this way, the end users from B are going to be able to find the lab on their own, either in the blockchain or in a decentralized app like a marketplace, and check its characteristics, its use conditions. And if they are interested in that lab, they will be able to access that particular lab thanks to whatever method is established in the smart contract. So it sounds simple, but it has some advantages over the traditional way of doing things. First, the representative figure in B disappears because the end users of B are able to discover the lab on their own and access it. Then A and B do not need to talk to each other because we have the smart contract in the middle. The same way A and B do not need to talk. All the first three things are basically automated and taken care by the smart contracts. And the somehow is also greatly solved because first we have a decentralized booking system available worldwide, deployed in a blockchain. We have the payment processing mechanism that are tied to tokens in blockchain. And we also have a good help in terms of authentication and authorization because, again, in the smart contract, you can define the API that you have directly to connect with IoT platforms, VPN solutions, or whatever you need. And then also very important, the last issue I mentioned about difficulties when sharing labs is, for example, asking for a refund when the service is not working. For that, you need auditability, trace records, which is also provided by blockchain, and also very important in academia, certifications for when someone uses something or what he does with that. Now, how is DecentraLabs doing all this? A little bit more in detail, let's say. What is our, let's say, architecture, flow, and everything? So for that, I have this slide here. So let me warn you, this is the most boring slide probably in the whole presentation. And what's even worse, I haven't prepared any joke for this slide, so it will be even more boring. And I have to spend quite some time here to explain everything properly. So, well, basically, we have 4 subsystems or components in the ecosystem. The first one is the marketplace. This is the front end app in which users would come, connect their wallet. I'm only going to talk about the wallet access, even though we are also working in an institutional access, but I'm leaving that aside from this presentation. It's still on the works. I'm going to focus in the wallet access for now. They connect their wallets, they can browse through the labs, discover them, read their characteristics, use terms, etc. They can make a booking or a reservation for that, and once they have the reservation, which is stored on chain, we will see that, they can click on the lab and access to the laboratory they have chosen. So that takes us to the second part, the lab provider infrastructure. This is basically what a university, research center, whatever, would have. Basically 3 important things: the laboratory setups, the computers connected to those laboratory setups to actually make the control, the automation, and so on. And then this part, the lab gateway, which is a module or a component that we have developed, and we are still actively developing in the project for our ecosystem, which basically enables outside connections from the institutional network to your institutional infrastructure. Then we have our decentralized backend, which are the smart contracts deployed to the blockchain. And here we have basically 5 important elements. The first one is a smart contract behind which we are deploying a smart contract to manage providers, another one to tokenize labs as NFTs, and another one for the reservations. And finally, we have the ERC20 lab token to make the payments and possibly for DAO decisions and things like that. The last part is the auth service, which is also a piece that we have developed. And it is basically, it can work as a bridge between the Web3 and Web2 world by connecting to the blockchain and returning something that is not so Web3. So let's see how it works. So basically, the student connects, or the researcher, the user, connects its wallet when he clicks on accessing a lab. Oh, before that, I should say, okay, to give the complete picture about all this, I should start from somewhere else before this, which would be explaining how a provider comes and registered using the provider smart contract. Once he's registered, how he mints or creates a lab, and then how a user makes a reservation. And once the user has a reservation, it would come this part, which is the access to the lab. But I'm going to skip those three parts because it would take even more time, make it even more boring, and I think this is enough. This is the part, probably more complex one, but most interesting one also. So I'm only going to explain the access to the lab once the reservation is done, and the lab exists, of course. So, as I said, the user would click on the lab to access it, and that would trigger its wallet to send the address to the auth service. Then the auth service replies with a message containing the wallet address of the user and attaching a timestamp. And this is done because it is going to ask the user to sign that message and return the signed message back to the auth service. And with this, the auth service, thanks to asynchronous encryption, has guarantee of that user being the owner of that wallet. So with that information, the auth service can go and ask the blockchain about that particular wallet address, and it's going to obtain basically information about what lab that user has a booking for and information about the booking in case there is a booking in the future, right? Or an active booking in this case, because he's trying to access a particular lab. So basically in the lab object, he's receiving information about the lab, like some identifier, the access URL, information about the authorization and authentication and things like that. And then in the booking object, the information is the date for the booking, the starting time, the end time, or if you prefer the time slot, the starting time and the time slot. And the auth service will check whether that's a valid active booking for this moment. And if it is, it's going to build a JWT, which stands for JSON Web Tokens. That's a standard used in authorization and authentication on the internet, in web applications. And it's going to sign this token and send it to the marketplace, which in turn resend it to the proper lab gateway, depending on the information received in the lab object. And this way it will redirect the student from the marketplace, directly from the marketplace to the service that is going to provide that laboratory in particular. Okay, was that too much? It's okay if you feel a little bit dizzy or sleepy right now. But we have to carry on. And as I said, I should explain a little bit more about the back end, the smart contracts deployed in the blockchain. So there were three parts there, well, four, but I merged the first two here. So let's start with the proxy. A proxy, for those of you who do not know exactly, is basically like a gate to route access to. So in blockchain and in smart contracts, this has a great advantage, which is the first one that I wrote there, which is that it allows developers to update their contracts and upgrade them without breaking time functionality. Because you know about the immutability property of blockchain, which means that if you are updating something, you need to redeploy the smart contract, you get a new address, and that means any application that were using your previous version, it will still use your previous version and not the new one. So thanks to the proxy, you solve that problem because client applications point to your proxy instead of the end smart contract. And that way you are able to deploy upgrades and updates and everything without disturbing clients and needing them to update anything. This property is not so important for us at this stage because we only have one client, the DecentraLabs marketplace, which we developed. So that's not that much important, but you never know in the future. And there is a second reason which was important for us. We wanted to maintain a degree of control in the initial stages of development because, you know, when you are starting, you need to be able to manage things a little bit more. So the proxy and the register contract behind it allowed us basically to define three roles. The first one is the contract owner, the one who develops and deploys the proxy behind them. And then we have the provider. Those are the users who can mint an NFT, edit it, even delete it in this case, and list them or unlist them. And finally, the users, who are students, researchers, even teachers, who can book a lab, cancel it, ask for a refund, access the lab, and so on. And of course, in the long term, our vision is to probably replace, well, not replace, probably complement, actually, the proxy by a DAO structure and reduce the importance of the proxy by also implementing DAO mechanisms. Now, I mentioned that we are tokenizing the labs as NFTs. We are using the standard ERC-721. With this, basically what we do is that each lab becomes a verifiable, non-fungible asset. Thanks to the standard, we have integration with wallets and with marketplaces around there. Again, that's not very important because right now we only have one marketplace, but you never know. The second one, which I missed, is papers of ownership. And of course, using all this structure, we can provide something that is very important, which is incentives to providers to ensure long-term viability, to make them keep their services online and working. And reservations are also NFT-ish because we have implemented them as an extension of ERC-721. The motivation behind this is that NFTs are becoming more and more used in different topics, like this example, online labs sharing, but also for ticket events or even in real estate. And for this kind of uses, you may need time-bound access, like it is written there. By doing it as an extension of ERC-721, what we are doing is we are enabling a standardized reservation and bringing a scheduling functionality to these NFTs. And then for those of you who are interested, there are also two related, maybe not standards, because I think they didn't reach that particular stage. I think they are EIPs instead, but never mind, 809 and 1201. But they didn't exactly fit our needs, and that's why we developed our own reservation solution as an ERC-721 extension. So we have talked about labs being tokenized as NFTs, and as most of you probably know, that means that there is an important thing associated to that, which is the metadata, right? So what kind of metadata have we defined for the labs? What things are important to make all this work? Well, the first part is details about the lab to be shared, something that identifies it or something like that. The access URL for the service, details about how the auth works, authentication, authorization. Then you have or whatever information about the provider, the name of the lab, a description of the lab saying this one is for this and this, etc. You may have images, pictures of the real equipment, and documentation like a manual on how to use it or what kind of things you can do with that equipment. Very important, availability conditions. For example, the date in which you want your lab to start being shared and the date in which you want it to stop being accessible by other people. But you could add more details there, like the days of the week that you want to share it, or the hours. We are not so far yet. For now, we only have opening and closing dates. But the ideas, the goal is to make it more rich in those terms. The time slots, which is how long do you allow the bookings or the reservations to be, could be 15 minutes, 30, 60, 2 hours, and of course, the price. So now let's do a brief exercise. No, I meant game, not exercise. Don't worry, this is not hard at all. It's fun, we can do it together. So the game is about deciding which of these pieces of metadata that we have seen should go on-chain or off-chain, which would be more optimal or normal, in the solution. So let's start with an easy one. Images and docs. Should that be on-chain or off-chain? What do you think? Off-chain. Yeah, sure, like, all these art NFTs that you see around there, most of them, images are stored off-chain because of storage reasons. How about the details of the lab, like how do you access it, the auth mechanisms, and so on? This is like the DNA of the lab. No one? Well, on-chain, exactly, yes, because as I said, these are truly important parameters that change the service. If you change this, you can change the endpoint of the lab. So if someone is thinking he's going to access something, maybe he ends up in something different for what he has paid or something. So it's important to be on-chain. Now, what about the description? This one can be off-chain too. It's not that important. Availability conditions. What about this one? Okay, so it's normal to think that this should be on-chain. But actually, after much thought, we decided to put this off-chain. And there is a good reason for that. When someone makes a reservation, they already have the reservation stored on-chain. And that reservation has the details about the starting time and the end time. So it doesn't matter if the owner of the lab changes the availability conditions because the reservation is already there and you have it. And that's stored and there is traceability for that. So you can leave this off-chain. What about the name of the lab? Very similar to description, right? This can be off-chain. What about the provider of the lab? Okay, this one is a bit tricky. Probably, I don't know, it depends. In our case, in our structure, this is on-chain because remember we have a provider smart contract behind the proxy, and that smart contract registers providers. So we have that information on-chain. Time slots, well, same as availability conditions, right? It can be off-chain because we have reservations stored on-chain with the information, so it doesn't matter if it changes. And then price, this one is a little bit tricky too. I could accept any of the two answers. In our case, right now, we have them on-chain, but that may change. That's because we are thinking on having quotes that would allow to change the price without gas fees and things like that. But it could change. Okay, so after that, let's go and see a little bit more about DecentraLabs, about probably the most visible part or element, which is the marketplace. So what you see in that image is the current state of the marketplace. We basically have two roles here, the ones I mentioned, without considering the contract owner, consumers and providers. So the functionalities we have already implemented in the marketplace are basically all the basic functionality you would expect. For consumers, they can browse the labs, they can book a lab, they can access a booked lab, and they have a user dashboard right there in the top where they can see the history of past reservations, upcoming reservations, a calendar with the reservations, buttons to apply for refunds, and that kind of things. And for providers, We have, well, first a button to register as a provider, which you cannot see in that image because this user is already registered as a provider. That's why it says UNED behind the wallet address. Otherwise, you would only see the wallet address when using the wallet to connect to log. And you have the provider dashboard. Once you are logged in as a provider, you have access to the provider dashboard, which is accessed through the lab panel in the top right part of the marketplace. So let's go and see it a little bit. So this is how it looks. I am already logged in as UNED, as you saw in the image. Now you can only see, oh, you cannot see it. So give me a second. I was sharing my whole screen, but it looks like it is. I'm going to stop sharing and I will try again. Here. No. Okay. So I think in the call it is being seen, but not here. So I'm going to try. Maybe no, screen 2 is not. Okay, so maybe I will try to share the browser instead. How about that? Nope. Then I think I'm running out of options. Can you see it in the call? In the call it is, but not here. Well, so I guess we will have to skip this part, which was quite interesting, I guess, but and I'm going back to the presentation then. And I can show it to you later if you are interested. Right, so, well, what I was going to show you anyway, let me explain it very briefly, is I was going to show you how to browse through the lab, what information you get. I was going to make a booking for a lab, pay for that, show it in the dashboard, how it updates and everything, then show the provider dashboard and see the reservation there, collect the tokens that I got from the new reservation I made, and that kind of things. And now this slide is to fill the different parts with what we have been discussing. So basically for the marketplace, we have what we have not been able to see in detail, but we got the image at least. Then for the decentralized backend, what we have done is we have deployed the smart contracts in a permissionless EVM blockchain on a testnet so far. We are not in production yet, of course. And in particular, we are using Sepolia testnet. You can check the source code of the smart contracts there, but even more, you also have the code and even documentation about them in our GitHub. Then the lab gateway, as I mentioned, is something that we have also developed, and you can also download this from our GitHub repository. It only takes a matter of minutes to download it and run it, because it is deployed as a Docker container, and it makes the onboarding process to the DecentraLabs ecosystem very, very easy and very, very quick. And then the last part, the authorization and the authentication service, it doesn't have, that's invisible, it's boring, so I didn't put any image there to replace it. But it is important to mention, and I forgot to do that before, that even though I put this here, and it kind of looks, or it totally looks like a centralized service, it doesn't have to be that way, actually. Right now, for the pilots, it is a service that we are providing in UNED to make it easier for lab providers to onboard. But you can also download this from our GitHub and put it to work in your infrastructure, in a different computer or a different system, or even in the gateway. You cannot see it here, but it is almost prepared to also have the auth service embedded in the gateway. So it can also be distributed, not centralized. And then, of course, the last parts are the laboratory setups and the computer PCs connected to those setups, which have to be provided by, well, the providers. And yeah, sorry, we do not offer you the lab computers because we are not that generous and we do not have the money anyway. But everything else is something that you have there in the community, in GitHub. So it's really, really easy to start sharing something if you already have the computer and a laboratory setup that is quite autonomous to be operated. Well, autonomous, let's say operated through a computer application. Doesn't have to be autonomous. So let's finish with a brief introduction about the community, and this would be like our call to action, basically. So the first part is something I have been mentioning a lot in the last slide, which is our GitHub repository, where you can find everything I have mentioned, plus a few more things, all under GPL version 3 license. Then, very important too is our Gitbook. That's a very good place to start learning about what we are doing, how we are doing it, how we are implementing things, and so on. You also have the documentation in the GitHub, but in the Gitbook is more, it's presented in an order way, more structure. The marketplace, of course, which we were not able to see very much, unfortunately. And finally, our socials. You can follow us on LinkedIn or on X and Twitter. You can engage in the conversations or just stay updated to the news. And let's wrap up with a thought that inspires us, or a sentence that motivates us, which is that science and knowledge and experimentation should be open and accessible to everyone. And we believe that DecentraLabs is a step forward towards that future. But of course, we will not be successful without people getting involved, engaging, and supporting. So I invite you to connect, to discuss, to engage with us, to participate, and we can start right now, of course, with questions if there are any. Thank you.
Thank you so much, Luis. Well, any questions about this application? And maybe you can connect it to the research that you're doing. And because I know quite a few some of you are working on smart contracts and different aspects of what Luis had discussed. So, yeah. Great.
One quick question. So what is the consideration behind using the ASLab token as the currency to purchase or to rent that lab service?
Well, basically to have, to have some control over the economy. We could have used F instead or something like that, if that's what you are asking as an alternative. Right now, for now, I mean, it's not written in marble or anything. Our idea is, for now, to at some point create the token. Right now, it's on the testnet, so it has no value, of course. But yeah, the idea is to have some control over the economy and be able to incentivize early adopters, early providers, also early users, early testers from the consumer side, to make the community grow and add more services, more users, and so on. That's basically the main idea for now.
Thank you. Going back to the question of tokens, do you see yourself having to have a treasury management function if you stick to the idea of having the tokens as a driver of the whole economy in the marketplace, and how's that going to work? Have you thought about that yet?
Not much. One thing I have thought, though, is when you go and deploy the auth service within the gateway, and you start giving this a lot of power, let's say, one option is to force somehow for the gateways to stake the tokens, so that you try to link the quality of the service to the stake tokens and apply slashing or that kind of mechanisms in case the service degrades. Everything is with the idea of keeping a healthy ecosystem in which services are alive, working, not dead, and promotes the good use and the good work and the good offering of that. But we haven't still worked too much on all the DAO things, treasuries and things like that. We have in the Gitbook some details about the tokenomics, but they are still quite early ideas. And again, nothing at all is written in marble. The project has been going on for 7 months, so very little, and we have a lot of things to do ahead, step by step.
I think the marketplace is not showing.
Oh, wow. So, perfect. So it's all on its own, great. So yeah, let's do the short demonstration here of how it works. Well, the information you can see of the labs here in this home page of the marketplace is basically the name of the lab, who the provider is, and the price per hour, right? As you saw in the image, there were like 6 of these fictional labs, and I say fictional because they are not yet working. These are real labs that have been working and are working in UNED, online labs, but they are not integrated into DecentraLabs yet. We actually expect to have the first labs working maybe in 1 week, 2 weeks, with Chile and the first one from UNED. And we are going to run the pilots for the last 2 months of this project, which is a 9-month project for now, even though we are extending it. So, as I said, these are for testing purposes. So the other ones are not visible because they are not listed, but you could click there in the filter and list them, well, not list them, see them. You can see they are not listed as it is set there. So if we access one of the unlisted labs, you will get the message saying that the laboratory is currently unlisted, not available for booking. You cannot book it. Even if the button was enabled, you would not be able to do it because the transaction would fail, of course. But we are trying to save that kind of problems to the end user. You have documentation here, you have more images. These ones are fake. The only real one is the first one. You have, keywords, categories, all that information that is in the metadata that we have been discussing. Now, if you go back to the homepage of the marketplace and we now click in a lab that is listed, basically you have the same information, but you can book the lab, right? So, okay, to do that, first, as I said, I am logged in as a provider already, UNED, okay? So I'm going to book my own lab because I am very weird. And I'm going to give money to myself and spend some money in gas and everything in the middle. But it's easier for demonstration purposes. So I'm going to do that. I click on Book Lab, and this will take me to the book application inside the marketplace. So here, basically, you can switch between the different labs that were listed in the marketplace, just these 2 for now, for testing. And you can also see the slots, the days marked in the calendar for which there are slots that are already booked. So, for example, there is a booking for tomorrow, 26 at like 8 o'clock to 8:15. So if I try to make a booking for that date and at that hour, this will not let me do it. Again, even if the UI would let me do it, the transaction would fail. So it's better not to allow the user to do it. You can also see that this is giving me the total price of the reservation. 1 lab, because I'm going to book 15 minutes and the price is 4 lab per hour. So that would be one lab for this time slot. Usual checks in Web3, checking that I have sufficient balance, that I have already authorized or approved the spend of and the limit of the tokens in this case. Of course, let me see if I can, yeah, here. Of course, that's because I have these lab tokens. I have quite a few of them, so I have enough, and I can make the reservation. So let's do that. Let's have it for 30 minutes, for example. I click on Make Booking, and this fires the transaction. This says I'm going to pay 2, and we confirm. That's the gas fees. And then the transaction is sent on-chain, confirm, and this changes to indicate that the reservation is still pending because we divide the process in 2 steps. There is a reason for that, but I don't want to talk about that right now. And now it is confirmed automatically. And you can see that also in the calendar. Oops, sorry about that. Well, you should be able to see it. Yeah, there it is. Right, so now what I can do is I can go to the dashboard still as a consumer, still as a user, and see the reservations. So I can see the reservation I just did. No, here, that should be here. This one, and some others I have done for testing in different labs. This one you were not able to see it because those are in different labs, but I have the list of my upcoming bookings here, not only in the calendar. I have my past bookings here in case I want to apply, I need to apply for a refund. The mechanism for that can be really complex. There are a lot of things to consider. We have not solved the problem yet. We are moving towards there, but there are lots of things to consider and take into account to decide and measure whether the service was good or not, and how you manage that kind of things. I can cancel my bookings and so on. So if I now go to the lab panel as the provider, not the user, in this case, I have my interface to manage my labs. So basically I have the basic electronics lab in which we just made the booking, I believe, and another one which is not listed. You can see this one is listed, this one is not. I could list it instead, I could delete it, edit it, or whatever. So if I want to add a new lab, I can do it from here, just fill in the metadata that we have seen, like images, documents, opening dates, closing dates, so on. You can see an example of that here, which is already filled, or here, because in the other one was with an external JSON file, right? And I can collect what I have earned with my laboratories, right? So if I click in collect all, this should tell me that, I have, okay, so demos have to fail. So this one is not going to work because I got some wrong state at some point. But this one should give me the money the lab tokens that I spent in the reservation. So we will need to check it out. And finally, if I log off and I am not identified as a user, of course, I am not able to book a laboratory. And if I log in not as a provider, but as a simple user who just came for the first time here to this marketplace and connects its wallet for the first time, this is what I would see. It's the same, except the lab panel gets replaced by the register as a provider. So if you're interested, you can fill this to send your expression of interest to register as a provider so far. And the rest would work the same, of course. You can still browse labs, book them. You have the dashboard, which for this user is empty because I have never done anything with this account. And that's basically the demonstration that I wanted to show for the marketplace. Yeah, bye-bye, Vicky. So, any more questions now? Yeah.
So first of all, great presentation, right? And it contains not only some technical material, area. Also some insights about the exciting application. I have one comment and one question. But the comment is basically a follow-up from Siri and Vic. Basically, we know that nowadays people in Web 3 are considering multi-tiers of token economics. Why? Because on the one hand, we want utility, right? For utility tokens, they just pay, right? The usage, as you mentioned, we hold them more or less stable, right? Even we can think of using stable coins for this purpose. Right? But on the other hand, as a Web3 project, we have governance, we have community building, right? So this is a different maybe functionality, and we can call it governance tokens, right? So that's why one direction is to introduce at least two tiers of tokens. One is the so-called utility token, the second is governance token, but you need to define the relationship between these two tokens in a simple and clear way, right? And it turns out that it's not a huge amount of work. A concrete example, very new, the Babylon project, I think started by a Stanford professor, David Shear, right? And first, Babylon used only one token, and then they realized, governance, utility, they're kind of
mix.
yeah, right? So then they, very recently, they decided, they tried to convert their one-tier token economics into two or even three, or maybe two at this time, right? And into two-tier token economics. And then they did some like a hackathon, or maybe just a few, I don't remember the exact number of weeks, right? But definitely less than 1 month, and they achieved, right, this conversion. I think in your case, or maybe in our case, because I'm also an advisor, right? So maybe this conversion is easier. Why? The Babylon project itself is an L1, level 1, and for like a level 2, right? I think maybe like this conversion and it can be made even like faster and easier. So this is like a kind of observation, as you mentioned, right? For the token economics, it's a little bit like undecided at this stage, right? This stage is mostly about the basic technology and use cases, right? So maybe this two-tier or even three-tier structure could play some role in the future, and maybe we will discuss.
Yes, absolutely. I mean, it makes perfect sense to have both utility and governance in the ecosystem in this project. And I am very far from being an expert on tokenomics. So any help, any advice in that sense, like this one, I would totally check Babylon for sure. And I hope to count with your advice, maybe in the future, to define better tokenomics and so on, is very welcome. So thank you for that. And I'm sure.
A quick question, because nowadays AI is so powerful, right? My question is, how do you envision the role of AI, right? Like a for maybe future project development?
Yes, I actually have a very nice idea, several ideas about how to get AI here. Basically, it is related to lab automation. So far, what we are thinking is we are giving access to lab app computers that you operate, like the ones I showed at the beginning of the presentation, the ones that my group have developed. Something like that, something that you interact with the graphical user interface, and that in turn moves the motors, take the measurements, and so on and so on. But with the new advances in AI, lab automation is becoming much and much easier. And what we are thinking is we can deploy some edge AI capabilities to our lab gateway. We can get the MCP, you know, what's the name? Whatever context protocol, model context protocol, exactly, thanks. Which you know it because you mentioned it, but for those of you who do not know it, probably most of you, they advertise this like the USB for artificial intelligence. So basically, if we put that, we would run any computer application run in the computers with this connector, and we would be able to, for example, allow users to operate the lab with natural language, like saying, okay, run this experiment, stop it when it reaches limit 1, save the data, whatever you want to write, describe the experiment, that could work in the lab, as long as the lab application has support for that particular task. I mean, if you tell the system that you want to change the label of the x-axis in the graph 1 and the app is not prepared to do that, that's not going to work. But if you have the tool to do that, you can link those as an API, let's say, those options of the graphical user interface and app from the MCP deployed in the lab gateway. So that's one thing. Of course, that also easily translates in being able to operate the labs with your voice. And there are more things that we have in mind, other use cases. So for example, another use case is the same technology, similar, would have to be a different model, like a Bayesian inference model, but also with MCP, we connect to the state of the remote session to the computer to check whether the lab app has been opened correctly, it is running correctly, it has closed correctly, the session has ended correctly, and so on. And this would allow us to bring like self-restore to the sessions in case something failed. So it would make, we expect, it would make the lab sessions, the lab connections much more reliable and robust, which is a good thing. These are two examples of AI applications that we could deploy in the edge, just in the same container, in the same element, that would enhance the system very much. I have a couple more of ideas somewhere written down in a document. I cannot remember them right now, but if I go back to my notes, we can discuss them for sure.
Very interesting. Thanks a lot. Any other questions?
Yeah, go ahead, please.
Is there any authorization when registered as a provider? Because
yeah,
this could be a scam.
Yeah, that's a very good question. So let me go back to the marketplace here. So here, right now, this is very, very easy, very simple. Right now, this basically fills an expression of interest, and it comes to me. And I basically check who you are, see your affiliation, or engage with you in a very ad hoc way. And if you are a trustworthy guy, I will just give you access as a provider, and you would be a provider. Of course, we are going to automate this, of course. One option is to have governance, for example. The other option, which I like the most, is connecting with institutional accounts, institutional logins. So that's one of the parts that is still in development. But basically here, when you click in institutional login, this would redirect you to an IDP, to your identity provider. In this case, this is connecting to Edu-cation, an international interfederation of authentication federations. Here we have the Canadian Federation. I think most of the universities and research centers, not all, but many of the universities and research centers in the world are there. Here you can only see the ones in Spain, because right now I'm limiting this test to the identity providers in Spain. But this is connected to Edu-cation, which is international and has basically many institutions there. So if you log in here with your institutional account, I haven't done this for a long time, so I hope it works. But the idea is I have logged with my teacher account from my university, and then this redirects me to the marketplace, or it should, because I haven't tested for months and months. And then I should be logged in. It is working, but it is not implemented. So you can still see the login button, but here I would already be logged in, as a potential provider, because I am receiving the information about this user, and in my case, my account identifies me as a teacher. So if I have the role of teacher or lab technician or high profile administration or something like that, the system would automatically recognize you as a potential provider for the ecosystem. So it would give you capabilities to register labs and so on. But for now, it is very simple. You send your expression of interest and I approve it. But we are still testing things in very early stage.
One more question. Like, it's actually not about the DecentraLabs, it's about the labs. So I believe, like, in your context, all the labs are expected to be like ready to use remotely, right?
That they are expected to be what?
Like ready to be used remotely.
They have to be ready to be used from a computer, from a computer app. Yes.
Yeah. So to what degrees are those labs prepared for this kind of remote usage?
If your lab can be fully operated from an app in the computer, that's it. That's enough. But if it needs, of course, manual in-person manipulation, then of course it cannot be fully remotely operable. Maybe some parts can, maybe some parts cannot. So for those experiments that still require some hands-on or in-person manipulation, we could of course extend this and try to add in the usage terms some kind of agreements about, for example, if you need to get information about some sample, and you need to deliver that sample to the particular laboratory. But once it is placed in the tray by someone, maybe the lab is completely autonomous, and there are many chemistry and even biology labs that are becoming more and more autonomous, like Hang Lab here in UBC are doing. So you could also implement the agreement conditions about the logistics of the lab in the smart contracts. You could also define that kind of things when you need to deliver something to the lab, or when you need some help from someone in person in that particular lab. You could also establish some conditions for that in the contract and have them like other kind of conditions that you are implementing. Of course, tracking that is more complicated. There are all kinds of problems, but you need to go step by step. And of course, the first step is to consider more autonomous labs, not those ones, because they are more complex, and then move from there and see how far you can reach.
Yeah, great. Thank you for the answer.
I guess there are no questions from Zoom, Elena? Perfect. Well, so if there are no more questions, I want to thank you again for attending, for your time, and for spending some time here listening to me. I hope you enjoyed it, you find it interesting, and
Very happy to have you here. Let's stay in touch.